Now we're looking at the latency of 4 different channels of relay. We have 3 matched relays and then 1 older version. And so you can see that each one is being fed still from the 3 hertz 10 volt signal generator. Actually that should be looking at channel 2. So that's the output that we have on. That is feeding into our relays, and then the relays are triggering our LEDs, and we're probing from the LEDs as well up here to the oscilloscope. So channel 1 is yellow, channel 2 is pink, 3 is blue, and 4 is green, and those are in order as the voltage flows. So yellow 1 actually receives current first, second, third, fourth. So what's interesting is our one oddball, actually older relay is channel 4. Channel 4 is green. Green is actually the lowest latency. So we're actually triggering off of green. It's the first one to trigger, so that's interesting. And then we go in order of voltage. So yellow, pink, and blue. Now I've tried this with different lengths of cable, jumper wire, because right now we actually are jumpering from one relay to the next. But even with longer relay wire or home running the relay wire, there doesn't seem to be any noticeable difference in the latency from one to the other. Obviously, if we went with a lot of cable, we could eventually introduce a delay, but what we are seeing here does seem to be the various delays of the individual relays, not the wiring per se. So if we move our trigger, so looking at our yellow, we're getting what would appear to be about 800 nanoseconds. And if we look at our pink, we're getting about 2.725 milliseconds. And if we look at channel 3, and it varies a little bit trigger to trigger, but we're averaging what looks like about 4.7 milliseconds. So quite a bit of differentiation. 4.7 on the long side and microseconds on the short side.